In this one, z is normally distributed from 0 to 1. We want to find x so that the probability z is greater than or equal to x is equal to 0.72. So I always draw a picture. So we're saying here's some specific x value and the area to the right is equal to 0.72. Now looking at this 0.72, that's over half, so I might actually want to redraw this so it's slightly to scale so that it looks like more than half of 0.72 there. Because if it is 0.72 and that's more than half, I realize that this x value should probably be negative, and that just kind of gives me a good way to double check my work. So now you're going to think, okay, I want to find which x value or z value has a 0.72 area to the right. But my table doesn't give me areas to the right, it gives me areas to the left. So over here, let's figure out what is 1 minus 0.72. Okay, and that's going to give me a 0.28. So I'm going to go to the table and I'm going to look at 0.28 on my normal table. So I'm looking in the area part, which is in the middle, for 0.28, or as close as I can get. Looks like this 0.2810 is the closest, so it looks like z is going to be negative 0.58. So z is negative 0.58. So this here is our negative 0.58. So x equals negative 0.58. Our textbook used an x. I like to, anytime you're doing anything standard normal, I like to still call it a z, which is why you heard me saying that. But negative 0.58 is the value that splits the z distribution. So there's 0.72 to the right and 0.28 to the left.